now that we've covered all computational thinking, we can go on to program design. So program design is all about solving problems. If you can't solve and articulate the problem by hand, you can't solve it with code. So this is more of the logic part. There's three key strategies you should be familiar with when articulating and testing algorithms. There are pseudocode, flowcharts, and trace tables. I'm sure a lot of people, many of you probably already familiar with pseudocode, so quickly go through that. Pseudocode is basically structured English. It's intended to communicate an algorithm to other programmers or to yourself, regardless of the programming language. So pseudocode is not language specific. So please note, this course requires you to be able to create as well as interpret and analyze pseudocode. So this is a really important part of IBCS. So since provided that examiners can see the logic in a candidate's response, regardless of language, it will be credited. No marks will be withheld for syntax errors. That's one of the nice things about IB. So since there's no fixed syntax, you can just use pseudocode. But however, IB has specific grammar that will use to ask you questions in pseudocode. So although you can use whatever syntax you want when you're writing the pseudocode, as long as it's comprehensible and it makes sense, they'll ask you questions in pseudocode are adhering to a certain grammar. So although you're not obligated to follow their syntax in your response, you won't lose credit for doing so. But you should be familiar enough with their syntax to be properly interpret the questions they give you. Pseudocode examples. So here we have a set of pseudocode. What is the algorithm doing and what is the error? So if anyone wants to try this problem, pause the video right now and do this problem. Okay, here's the answer. This algorithm is counting how many of the input numbers are even and how many are odd until the user enters in 0, which ends the loop. So see right here, loop while n is not equal to 0. That means when n is equal to 0, then this loop will end. Now the error, if anyone found this, is the odds variable is not initialized. Up here, you see evens equals 0, but we don't have initializing an odd number, so you want to put odds equals 0. So a very easy problem. There are other examples of pseudocode from the official IB syllabus, and I will link them in the description. The second type of program design is flowcharts. So IB exams won't even require you to create your own flowcharts, but they will present flowcharts to you for analysis and interpretation. And so you have to know how to recognize the symbols. And also you should just know how to do flowcharts because they are a useful tool in your own programming. So some general rules for making flowcharts. You should always format your flow from left to right or top to bottom. You should always run your return lines under your flowchart, making sure they don't overlap. Maintain consistent spacing between the symbols, and use a correct symbol for each step. So examples of this are diamond shapes for decisions, rectangles for processes, start and end shapes should be the same, etc. So here we have the symbols. The source for this is linked in the description, but basically this symbol is a terminator, which means the start or end of a program. You want to start with this, and then you want to proceed with other ones. The second one, this rectangle, is process, a task or action that needs to be performed. The arrows indicate flow, what part of the program should be executed next. So you will flow from a terminator to a decision or a process, and then end to flowing back to a terminator. And a decision, which is a diamond, is required to move. A decision is required to move forward. This could be a binary, this or that choice, or a more complex decision with multiple choices. Make sure that you capture each possible choice within your diagram. Here's an example of a flowchart. This is from the officially IB provided documents. I'll link them in the description. But this doesn't have the terminator start, but just pretend like the terminator's here. So there's going to be a start here, and it'll flow into a decision, right? And then you got here a process, which is an output, and an output here. So what this is doing is converting to pseudocode. If max is above 0, then the output should be positive, and if it's not, see it says no, it'll flow to output not positive. And it'll end here, and ideally this would flow back into a terminate. Okay, last type is trace tables. A trace table is a method of performing a manual computations on an algorithm. It is useful for error checking on simple algorithms, and on the exam you should be able to analyze and create trace tables. There's some problems related to trace tables that might appear on exam or practice problems. These can include creating a trace table to identify the error within a given algorithm, determining the number of steps in a given algorithm will be performed for a given input data, suggest changes in an algorithm that will improve efficiency. One example is using a flag to stop a search immediately when an item is found, and to justify algorithm efficiency, correctness, reliability, or flexibility. Okay, we'll run an example of a trace table. Okay, so this is an example of a trace table. So right here you'll have the algorithm. You start off with number 3, and you see this is an example right here. Your number is 3, line 1, line 2, print number. So how would you do this? You would put, since the number is 3 and you're printing it, the output is 3. So you would write 3 right here. And for this one, for I from 1 to 3, this is a for loop. So when I is equal to 1, that is the first time you're running through the loop. In the first time running, on number 4, the number would be 8, because number right here is 3, right? And number plus 5, 3 plus 5 is 8. And on your second iterate, and then you would print the number, because it says print here. Print number 8. Step 5. And on line 6, we go through the second iteration. So when I is equal to 2, our number will be 13, because what is 8 plus 5? It's 13. And you would add that to the output, and then so on. So third iteration, 13 plus 5, 18, and output 18. So go all the way down here, and then last line is print question mark. You would just put that right there. Okay. Oops. Okay. So here's the answer. It's pretty self-explanatory, and you basically just want to do this when you have it's a way of debugging mostly. So if you have a bug in your code and you don't know what it is, you want to run through all of your loops, run through your algorithm, and it'll help you understand your output and hopefully find the bug. Okay, thank you all everyone for watching. In our next class we'll be covering some more difficult topics, so it'll be the part 2 of topic 4, which covers standard algorithms, algorithm efficiency, and programming concepts. Out of these, standard algorithms is very important because we're learning about searching algorithms, so stay tuned for the next class. Thank you.